So next, I think it'd be a good exploration for you guys to just look and see the things you were talking about. Um, so we said that we had a charge in the magnetic field. How would it behave? So I'm going to shoot a electric particle in this field here. Now, what these dots mean is the magnetic field is coming out of the paper, and um, and I'm going to use a one electron charge, so it'd be a negative charge coming in at this speed. Here's the field strength and the charge's mass. You could play with that. So you fire the particle and you see how it behaves. It doesn't go into the field or come out of the page, which is the direction of the magnetic field, but instead it's moving in an entirely different direction. Now, if I change the magnetic field to be going into the paper instead of coming out of the paper, which is presented by these crosses, you can think of it as an arrow going away from you or coming at you. Arrows going away from you would look like this. Arrows coming at you might look like that. So if I do the same thing here, you see that now it turns in the opposite direction. And so what's happening is this using that right hand rule, and you can determine the direction it's going to be moving. And so that's something you can use to just explore and see how a charged particle behaves when it comes into a magnetic field. So it's coming in this dimension. The field is coming out of the paper, but itself turns in the third dimension. That means the direction in which the force is neither in the direction the object was moving nor the direction of the field, but in the third direction. Okay, and which third direction can be determined with your right hand rule. The other one was the magnetic induction. I was showing you about how a changing magnetic field near a wire can cause current to flow. So here's a loop of wire. And this, if you pay attention here, that tells you whether there's power going through there as it lights up if there is. And so I'm going to move this thing horizontally. And you'll see as soon as it starts to come into the magnetic field, this light comes in because the magnetic field going through the loop is changing. There's more and more and more as it comes through. What you'll also notice is once it gets in here and the magnetic field is no longer changing, there's no more current flowing anymore. And then again, when the magnetic field starts to change the amount that is going through the loop, then we have this thing lighting up. Now, if I were to start again, let me get this thing off of this end and bring it back on to the other end. So I'm not going to let it come in. Again, you'll see that as long as there's no magnetic field lines cutting these coils, this is okay. The moment it does, the magnetic field line is changing. The amount of field lines going through here, we see this thing going on. Now, when it comes right in the middle here, I'm going to stop it once this thing turns off. So I'm going to stop that right there. Now I'm going to rotate this. And you see that if I rotate it, I'm always changing the amount of magnetic field lines going through those coils. And so this thing lights up. And that's really the process with which your generator or your motor works, is a rotating magnetic field within another magnetic field. Okay, so that's just a demonstration. It'd be a fun thing for you guys to play with, to understand how Faraday's law works, and that you can actually create a magnetic field, electric field or electric current by varying the magnetic field that's around the coil of the wires that are going to be passing the current. So that should pretty much wrap up your exploration into magnetism. If you have any questions, please feel free to reach out to me on Remind. Everything in here should be kind of making sense. It's kind of stated, and then information that you might not be able to find, you could go ahead and look in the PowerPoints. Explore motors and generators, and a deeper dive into magnetism videos are optional. These are for you to see if you want to see a little more detail on how motors and generators are formed, as well as take a deeper dive into Faraday's law and other things. Go ahead and answer your exit ticket when you're done, and I shall see you again soon. Please reach out with any questions you have. Remind, Schoology, or email. I'm always waiting to answer questions that you kids might have. Okay, bye for now.